Hello, good evening. This is another day that I want to welcome you back to our channel. So before we commence, I want to thank you so much for your support. May God bless you for me because you are amazing. Continue sharing the link so that many people can subscribe, become members, and start gaining maths experience. Welcome to our class. This is lesson number 2. The topic is sequence and series. Subtopic is geometric sequence, a continuation of our previous lesson. So today, I will like to make you aware on how we can be able to find any given term of the geometric sequence. Remember, I divided a geometric sequence in our previous lesson. So how do we obtain any given term or the number of terms of a geometric sequence? So that's where we will start from. So I will say to obtain n term of a geometric sequence we apply the formula the n term is going to be the first term times the common ratio raised power n minus 1. So this is the formula that we will apply for us to be able to find any given term of the geometric sequence. So once you have that particular formula, then it is going to be so easy for us to be able to obtain any given term of the sequence. Now, can we look at an example? Example 1. So we can say find the ninth term of the geometric sequence. Then we have been given 5, 15, 45, 135, etc. So that's our geometric sequence. And I want to remind you that what makes this sequence to be a geometric is that it contains a common ratio and not the common difference. So to prove that, you take the first two consecutive terms, which are 5 and 15, divide them. 5 divided by 15 divided by 5, it gives you 3. 45 divided by 15, it gives you 3. 135 divided by 45, it gives you 3. That means this sequence contains a common ratio. But if you take 135 minus 45, you will get 90. 45 minus 15, you will get that. It is not consistent. So it means it does not have a common difference, but instead it has a common ratio. Therefore, it is being termed to be a geometric sequence. So once you have been given the first 4 terms of the geometric sequence, can you be able to obtain the 9th term of the same sequence? Yes, we will use this formula. So our 9th term will be a r raised power n minus 1. Now, because this is what we are looking for, the 9th term is what we are looking for, our a will be always the first term of the sequence. In this case, it is 5. So we will say 5 times common ratio. Common ratio is 45 divided by 15, which is 3. Or you can say your common ratio is 135 divided by 45, which is the same as 3. So I will now put 3 here, then I raise it to power 9 minus 1. Remember, n represents the number of terms or the position of the term required to be determined. So in this case, we are supposed to determine the 9th term. So our power of n becomes 9. Therefore, this will be 5 times 3 raised to power 8, because 9 minus 1 is 8. Now, taking our calculator, we will dial 3 raised to power 8, which will be 6,561. Then we multiply it by 5, which finally will give us 32,805. So that is the 9th term of the geometric sequence. So I want us to look at example 2. I want us to look at example 2. We are supposed to find the number of terms of the sequence. Find the number of terms of the sequence. Find the number of terms of the sequence, which is 2, 4, 8, all the way to 128. We are supposed to determine the number of terms of the sequence. Remember, we are dealing with the geometric sequence, and you can be able to prove using the first 3 terms given. Because if you take 4 minus 2 is 2, 8 minus 4 is 4. You don't get a common value when you are subtracting consecutive terms. So that means you are not dealing with an arithmetic sequence, but instead you are dealing with a geometric sequence. Because if you take 4 divided by 2, you get 2. 8 divided by 4, you get 2. So it means this is a geometric sequence. So for us to be able to get the number of terms, we will apply the same formula of getting n term, which will be n term is equals to AR raised to power n minus 1. Raised to power n minus 1. So do we have power of A? Yes, it is 2. Do we have the power of R? No, but we can obtain it by taking 8 divided by 4, which gives you 2. Next, do we have the last term? So our n term here will be the last term, which is 128. So let's come back here because of space. We will now say the n term now, which is 128, is going to be equal to power of A, which is 2, times power of R, which is 2 again, raised to power n minus 1, because we don't have n. So that's what we are required to determine. So we can decide to divide by 2 on both sides, so that these 2 can cancel it out. 2 goes to 128, 64 times, which is the same as 2 n minus 1. So we can change 64 so that we can write it in index notation. 64 can be written as 2 raised to power 6, which is the same as 2 raised to power n, raised to power n, raised to power n minus 1. Since from indices, when the bases are the same, we just equate the powers. 6 is going to be equal to n minus 1. We take now this 1 to the other side. So 6 plus 1 becomes n. Therefore, 6 plus 1 is 7, which is now equivalent to n. And remember, n represents the number of terms. So the question wanted us to find the number of terms. So we will say n is equals to 7 terms. So our terms are 7. Next time we will look at series. We have a geometric series, which sometimes is known as geometric progression. We are going to look at arithmetic series. Arithmetic series is what sometimes we find it being called the arithmetic progression. So we will look at the AB and the GP in our next lesson. So if you have any question concerning the geometric sequence or the arithmetic sequence, I welcome you to go down there to the comments. You ask your question there because I'm here for you. Mwalimu Nyambani Math channel is yours. It is there to help you. Any question you will ask, I promise you, you will get the feedback. Like now, this topic known as sequence and series, it is someone who requested me to upload videos on it, and I've done it. And I want to thank that particular person to continue asking because he indeed trusts this particular channel. This channel will grow because of your support, so kindly keep watching, keep subscribing, share, and like. God bless you. Thank you for listening to me. See you next time. Bye bye.